Hello class, today we are going to be talking about scientific notation. A long time ago there was a king, and I think that this king really liked the beach because one day he was wondering how many grains of sand are there in the entire world. And he was like, I obviously don't have time to go count all of them. So he went and asked his friend named Archimedes, who just happened to be a brilliant mathematician at the time. And so he said, Archimedes, go figure out how many grains of sand there are. And he's like, I'm on it. So using some really fancy mathematic calculations, he comes back and says, King, I have a number and it's really big. And the king says, all right, well, write it down for me and we'll see. And so Archimedes starts to write the number down. And after a couple of seconds, he realizes that it's taking way too long. He said, King, there are 63 zeros after this number. I don't want to write it down. It's taking too long. So the king said, well, why don't you come up with a way that we can write numbers shorthand? He was like, all right, I'll do that. And so he decided that he was going to create something, and now we call it scientific notation. And the reason we call it scientific notation is a lot of times this is used in science because there are some really big numbers in science and some really small numbers. And so it helps scientists be able to write things in a more concise way. So the definition of scientific notation is just a shorter way to write very large or very small numbers. And so as we look at our notes, the key things to remember are split a couple different ways. So the top part, we are going to be talking about scientific notation. This is the form of it. For the bottom three, we are going to be talking about how to convert to scientific notation. So let's look at what scientific notation actually looks like. What did Archimedes come up with to write his number shorthand? The first thing that you have to remember is that there is one non-zero number in front of the decimal. One non-zero number. This is really important that it's non-zero. We don't want a zero in front of it. It has to be one number. So it could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. Okay? The second thing is that we are going to be multiplying this one non-zero number in front of the decimal by the number 10 raised to a power. That is either positive or negative. So let's give an example of scientific notation. Let's say we have 6.93. Notice there's only one number in front of the decimal. And we multiply it by 10 raised to the 7th power. This would be a number written in scientific notation. It follows the first two requirements. Or we could do something different, like 1.5 times 10 to the negative 5. And this is also a number in scientific notation. So every number written in scientific notation must have these two requirements. Now, how do we convert a number to scientific notation? The first thing is called a place value shift. And we talked about this when we were talking about ordering real numbers and converting percents to decimals. A place value shift happens when you move the decimal. Now, you're not just moving the decimal however you like oh, I feel like moving it 5 times today. You have to look at the exponent of your number to know how many places to move it. So you're moving the decimal based on the exponent. So the number in the exponent is the number of times you move it. Remember that when we say a number is raised to the power, we're talking about the exponent here. So power and exponent will be used throughout this video. Make sure you know that they're the same thing. So when we're looking at a positive exponent, as in 10 raised to the positive 7, you are moving the decimal to the right because the number is getting bigger. So the number gets bigger, move decimal to the right. And if it's a negative exponent, the number gets smaller. So move the decimal to the left. Okay? So in this case, we would be moving the decimal right here to the right. In this case, with the negative exponent, we'd be moving this decimal to the left. Okay? So remember these 5 rules. They're going to be super important, but don't worry if you're confused. We're going to do some examples right now. So on the bottom of your page, over here on this right-hand box, it says standard notation. And standard notation is how you write a number normally. So that would just be writing like 1,500,000, something like that. It's the whole full version of the number. And scientific notation would, of course, follow our first 2 rules. So 10 to the number. Okay, so in this case, we have these 2 numbers that are in scientific notation, and we need to change them into standard notation. So first, we have 4.91, and the first thing we want to do is locate the exponent, which is 5. And it's a positive 5, so we know that the decimal is being moved to the right 5 times. So you have the decimal, move it with me. 1, 2, 3, 4, 5. So every place where you have a blank spot, you have to add a 0. So 4.91 times 10 raised to the 5th power is the same as 491,000. Down here, we find the exponent, and it's negative 4. So we have 7.6. We know the decimal is being moved to the left, and we're moving it 4 times. So 1, 2, 3, 4. Same thing as before. In the blank spaces, we add zeros, and we have 0.00076. Great. Now, let's do some of these over here. These numbers are in standard form, and we need to convert them to scientific notation. So, we know scientific notation has to have one non-zero number in front of the decimal, and we're going to multiply it by the number 10 raised to a power. So, the decimal of a whole number is always at the end of the number. So, we have to move it to a place where there's only one non-zero number in front of the decimal. Let's move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places until the 1 is in front of the decimal. So we have 1.56, and you only have to take the non-zero numbers because we can just assume that there are zeros behind this. 1.56 times, we moved it 10 times. And notice how 15,600,000,000 is bigger than 1.56. So if the number is bigger, we know our exponent is positive. So it's positive 10. So 1.56 times 10 raised to the 10th power. Over here, we have a decimal. And so we need to move this decimal so that there's one non-zero number in front of it. So 1, 2, 3, 4, 5, 6. So the 9 is in front of it. So we moved it 6 times, and we have 9.283. Notice that just because there's only one number in front of the decimal doesn't mean there's only one number behind the decimal. You can have as many numbers behind the decimal as you want, but there can only be one in front of the decimal. So we moved it 6 times, and notice that this number started as a decimal. So 9.283 is much bigger than this number. So for scientific notation, 9.283 is going to get smaller, and therefore we have a negative exponent. So we raise 10 to the negative 6th power. And that's scientific notation, how to convert from scientific to standard and from standard to scientific.